moving on to projectile motion. Where we started from? We started with just horizontal motion, right? A train moving side to side. Then we did falling objects, perfectly vertical. So we had perfectly horizontal, perfectly vertical. And we're moving into projectile motion, where there's actually two things going on, when we have two-dimensional things going on. The idea, though, is we want to get vectors. We need to understand what vectors are first. And vectors aren't anything really fancy. Really, it's just if you need to draw a picture to show what's going on. Okay? A vector is going to be an arrow that represents either velocity, acceleration, force. Anything that has a number and has a direction can be drawn with an arrow, can be drawn with a vector. Okay? So, the idea is, let's say I fly due north. But wind is going to blow eastward. Okay? Well, which direction am I actually going to be flying in? Even if I'm aiming up north, okay, if wind is blowing my plane eastward,
Northeast.
it's going to be northeast. And that it can be drawn as a vector to figure out where it's actually going. Okay? It's the same thing with displacement. If I said I walked north and then walked east, if I want to know how far, what my displacement is a vector. It has a number and a direction. It'll be the same thing. We could figure out what those are. So you're going to see a lot of SOHCAHTOA, and you're going to see some Pythagorean theorem. I'm going to help you with SOHCAHTOA again, okay? I'll reteach it to you if I need to. But vectors really are just representing everything with arrows. Now here's where it can get trickier. What if instead of going perfectly north, I was going at an angle? Okay, what about instead of due north, I was going a little bit northeast? Okay, and what if what if the wind was blowing a little bit southeast? Well, with vectors, we can still figure out what's exactly going on, but it's just going to take a little SOHCAHTOA and a little bit of Pythagorean theorem to do it. Okay, so that's the idea that we're going into. Alright? So let me close this or move it. If I can move it. Can I move it? You get to that? Alright. So, we were talking about vectors today. And the idea is, and this is something that I didn't bring up our first day of school. When we first started talking about velocity and acceleration, we actually had the concept and talked to you about the concept of velocity when I talked about velocity versus speed. Velocity is a vector. A vector is anything that has magnitude and direction. Okay? 30 meters per second east. Negative 9.8. Those are all things that have a magnitude, the number, and the direction. Even if it's negative, right? Or east or west, that's just direction. The only thing, when we talk about speed, we talk about you going around a circular track, right? Your velocity was 0. Your speed had a number to it, just a distance. So, a vector, velocity is a vector, speed would be considered a scalar. Just a number, no direction. Okay? You're going to have a question on your test where I just say, where you need to know the difference between a vector and a scalar. And again, a vector just means it has the number and the direction. A scalar just has the number. Okay? Alright. Move this up a little bit. Just like that. Okay, so if we have vector versus scalar, just understand the difference. And then there's a little bit more vocabulary you need to know. Components and resultants.
Wait, what was scalar?
Scalar is just a number. So, if velocity is a vector, speed was a scalar. If displacement is a vector, distance was a scalar. Remember we talked about the confused soccer player. He runs 3 meters east and 4 meters west. His distance was I just said 3 and 4, right? Yes, sir.
I'm next door.
Okay. The two other things we need to know are components and resultants. Components are all the pieces that will make up the resultant. Okay? Sometimes the components are already perpendicular. You walk 3 meters east, then you walk 2 meters north, and you need to figure out what the resultant is. Sometimes the components could be first at angles, and you actually need to make them into smaller components. Okay? If I went northeast, and then a little bit more northeast, or a little bit more north and east than this one, I'm going to have to take these little components and make them into smaller components. Purely east, purely north, purely east again, purely north. I have to break them from these angles to pure vertical or horizontal. Okay, always perpendicular. With any vector, with any component, they always have to be tip to tail, the way you draw them. And I'm going to show, it's going to be easier when I show it on the other program here. But every component always has to be tip to tail. Okay?
What is that stuff and use geometry or what?
You can use geometry, I don't know, to solve for the resultant, probably. Something along those lines.
Do we copy that one?
Yeah, it's up to you. It's online. Okay, resultants always have to be from start to finish. So if I want to figure out what actually happened, I'm going to take my components and draw them all tip to tail. Okay, tip to tail. And then my resultant will be from the start to the finish. A lot of students will get confused because they'll draw either your components will be tail to tail or something like that, or you think that the resultant has to be tip to tail also. It won't be. Okay, if I draw a triangle that goes east that way and north that way, your resultant shouldn't be going down southwest, it should be going up northeast. Okay? Alright, so that's the idea. You're going to use, anytime you have angles, anytime things are not perpendicular, you have to break them down into the components first. Get them into perpendicular components, and then you're just going to do Pythagorean theorem or SOHCAHTOA, or a little bit of both. Alright, I'll pause it there and let you copy down, and then I'm going to move on to the other slide. Anytime you have two things that go in different directions, remember that a vector direction is important. Okay, so it's not just the magnitude, but also the direction. If you have two things that say we're going like that, and you want to figure out what the resultant is, you want to ultimately get a right triangle. So the idea would be this, you need to have to break down into its components, horizontal and vertical. Once you have the components, you now have your new right triangle. Okay, so what you would do is if you saw things where they aren't perfectly perpendicular, you'd get the pieces, you'd get the perpendicular pieces formed first. So I take this and use SOHCAHTOA and just get my opposite and my adjacent. Okay? And then my new right triangle to figure out my resultant. Remember, components always have to be tip to tail. The resultant always has to be start to finish. Alright, so if I have, get rid of the component, I have something that looks like that. Well, the components are already tip to tail, so if I want to figure out what it's actually going to do, what the resultant's going to be, I'm just going to have my Pythagorean theorem and figure out a squared plus b squared equals c squared. Okay? But if you have, let's say I had something else. Let's say I had on a worksheet, they're going opposite directions. Are the components tip to tail? No. So all you do is you move the arrows. Okay? You can have an arrow going, I can move this one, and this isn't really 90 degrees. You can have this moved over here. Just cross it out and redraw it. Okay? You can have this moved over somewhere. I can have that moved over there. So it's tip to tail. You can just move the vector. So if I give you two vectors on a worksheet and they're tail to tail, redraw it so that they're tip to tail. You just can't change the direction of them. Yes, sir?
What if it's not a 90-degree angle? What if it's like a...
Good question. If it's not a 90-degree angle, so I have something like this and like that, okay? Those two are going to be, they're not perpendicular. So all you have to do first is break them into their components. Okay, so all I'm going to do is I'm going to take the components. I'm going to do SOHCAHTOA. And I heard that. That big side through SOHCAHTOA. We'll be alright with it. Okay, we'll do SOHCAHTOA. We'll get the opposite and the adjacent here, the opposite and the adjacent there. We're going to still just redraw so that they're tip to tail. Okay, and your new right triangle will be this plus that squared. Okay, plus that squared. That will give you your new hypotenuse, your new Pythagorean theorem. So it's just a little bit of SOHCAHTOA, but to get your resultant, you just break down the pieces first if they're not perpendicular to begin with. So you get the perpendicular pieces and then add them up. A squared here plus b squared there will equal your c squared. Okay? So that's what we're doing. Okay? Well, I'm going to have I have two worksheets. One says vector practice. The other says honors vector practice. And we're just going to go through it.